meeting, right? It's got file sheet. Mine is okay. Yeah. So what's the logic for adder? For adder? A quiz interview question.
Carry out is. Oh.
I'll just write it this way: AB. So that's the logic. And these are the only two outputs of the 1-bit full adder. Are there any other outputs? No, just summation and the carry out. And so this one is being renamed as a generate bit. And this one is renamed as propagate bit. Propagate. You'll see why later. Propagate. Yeah, propagate bit. Sounds weird, right? Be like propagation. Yeah. So that's G, that's P. So CO can be rewritten as G or PCI, right? Okay. So this helps you design the structure of the carry-lookahead adder. It's a little bit faster than the ripple carry full adder.
Is this what's used for most stuff now, or does the ripple carry?
I don't know. I mean, so I think the one we have in lab is being used more often. I think it's a way better one than this one. Yeah.
Not the ripple. The ripple.
The ripple, yeah, I think so. Yeah. Mm-hmm. If you look at the size, the footprint of the full adder, we haven't done the high-speed full adder yet. It's next week. Yeah. So if you compare the size, I think it's only only a quarter of the size of the ripple one. Yeah. So the high-speed one we designed yesterday. So just refer to the notes. That one is better, and we are using that one for the lab. So you are going to work on that one later. You'll see. And this is another structure you need to know, right? It's a carry-lookahead adder. It's a little bit faster than the ripple one. There's nothing to do with this, right? Couldn't simplify anything, just extra gates. So for S, you just have to do this, right? Okay. Yeah, that's it. You couldn't change anything. So we're just trying to optimize the structure for CL, not S. So starting with, remember the 3-bit, is that the 3-bit one? Yes, it's a 3-bit one. For the ripple version, ripple carry full adder. C2, S2, S1, S0, C minus 1, that's how we labeled it. C0, C1, C2, right? So C0 equals G0 or P0 C minus 1. Is that correct? G0 or P0, yep. So G0 is A0, B0. P0 is A0 or B0. The carry is CI, right? So it's C in for the first one. Because CO is here, CO is here, so C in is actually C minus 1 in here. What about C1? So CO is this, C1 is G1 or P1 C0. And you have C0 here, so just substitute the C0 with this one.
Just keep going.
Intermediate carries,
Yeah.
right? So if you have a carry in, you can directly get CL. That's why it's faster. You don't have to wait for these ones. Sum is not doing anything. Oh, sums, yeah, you have to wait for sums, right? Sums, you couldn't change the speed to get the sums.
Yeah.
It's not this structure anymore. It's a totally different logic, and that logic doesn't have C1 and C1s in there. Only C minus 1. Do you have to wait for S? Yes, but it's going to be a little bit faster than just waiting for both. Yeah, C is always the slowest. You have more gates here. C2 is G2 or P2 C1, right? And C1 is this whole thing here, G2, G2, or P2 G1 or P1 G0 or P0 C minus 1, like that. Huh?
Oh, never mind.
Oh yeah. Just try to copy this whole thing.
Yeah,
here. What's next? Expand it. So C2 equals G2 or, so what's inside here becomes P1 G0 or P1 P0 C minus 1, right? This is and plus G1. So expand it here, put P2 inside, so P2 G1 or P2 P1 G0 or P2 P1 P0 C minus 1. Okay, so don't need C1 and C2 or C0 and C1 in there in order to get C2. It's going to be super tedious to build gates and let's add more gates. So this homework assignment doesn't practice anything but patience. Including the ALU. After you are really good at layout, but yes, you are still practicing all the commands. So see here, so all the A and Bs are being fed into the repo carry adder here like that, right? So if you don't need to wait for A and Bs, these are inputs, they are given. But however, for these ones, I think you have to wait until you got this one and then do the operation with A0, B0. Takes time to get a CL from these and then have to wait for CL and add it to these ones. So it's not affecting S probably.
Right, but where do we get the CI for the lookahead?
These are these ones, right?
Okay.
So S is not really being improved. The speed to getting S, the time to get S,
Okay.
it's probably not being reduced too much.
Branch off like in the middle, like there's certain points where we can branch off to get
Yeah, let's take a look at the schematic. Yeah. So the G's and P's are just A and B's.
Right.
They are given.
Right.
So they can get them probably instantly.
Right.
Yeah. There will be some delay. Yeah.
Where we get the C in for the sum.
Yeah.
Is the purpose.
Yeah. Let's take a look at the homework assignment.
Ooh. Oh, this would be
Yeah, just copy and paste and wiring things up, right? So see, these are G0, P0, G1, P1s, right?
Yeah.
So these forms CO and C1s. Yeah.
I see. So we're calculating the carry
Yeah.
outside of it.
Yeah, so here's S, right? S0 got C minus 1, C0, C1.
Okay.
And C1 is being calculated, is being generated where?
Oh, it's on the left.
C1? Oh, yeah, here, right? Yeah.
Okay, that makes sense.
Yeah. Yeah.
And this is smaller than the original, the ripple carry full letter, or is it just faster?
It's a little bit faster for C2 if you look at the diagram.
Right.
Yeah, so this one of the tasks asks you to repeat this simulation to verify that this is faster. Is it faster? Yeah, so C2 here was being, generated earlier a little bit earlier than this one.
Okay.
Yeah, derive the logic function of the logic function or logic expression, logic function of the Carry-Lookahead flighter, and build a 3-bit ripple carrier flighter in LT-SPICE. Run simulations for adders. Use the 2 inputs. It's up to you. You don't have to use this as long as you can verify it. I don't care, right? You don't have to use this one. So the reason I do this is because if you toggle this one, it's gonna generate the C2 because you're adding 1 to it, right? It's gonna generate the C2. If you add a 0, it's not generating it. So you can see this rising edge to compare. Make sense? Yeah. Okay. So I want to run. I think so. Yeah. Let's see. Yeah. Next Friday. Is it next Friday? Yes. What else are going to do recently? The kid. Wire bonding way. I haven't planned for that yet. Yeah.
We'll teach ourselves. We won't break it. Nothing to break.
Scary.
How much is the wire?
$20-something.
Oh, I'm gonna stay away from that thing.
Don't let the schoolers in there.
Don't let them in there.
Yeah. So the tutorial 1 and 2, right? Tutorial 1 and 2 for cadence.
Yeah.
You all got the license, the account.
I don't think I've got.
Oh, you don't need the email.
Oh, okay.
Mm-hmm.
And we can do that on the lab.
If you connect to the college's network, any computer, even your laptop, it's okay.
We won't need to download anything.
There will be a terminal. It's called MOBA terminal. MOBA terminal. It's just a terminal opens up what? It's a graphical design. Connecting with the SSH or something. I'm not very familiar with that.